Morning, everyone. My name is Xuan Liu. I am the Research Director for Southeast Michigan Council of Governments, or SEMCOG. Today, my colleague, Chad Misiuk, and I will show you some of the data and map projects we work at SEMCOG, and to illustrate how we use data to help community and regional planning. I will start with some general comments with one data project as an example, and then Chad will talk about more detailed and technical stuff, particularly for our web application development and GIS, and then we look forward to your comments and questions and discussions in the end. So when Chad and I talk about the Southeast Michigan region, we're really referring to these 7 counties in the southeast corner of the state of Michigan. That includes Wayne, Oakland, Washtenaw, Macomb, Livingston, St. Clair, and Monroe counties. City of Detroit is the largest city in the region, but also includes cities like Ann Arbor, Dearborn, Warren, Pontiac, Port Huron, Monroe City, and Brighton City in each one of those 7 counties. Half of the state of Michigan's 10 million residents are working and living in this part of the region. Just a little bit about SEMCOG. So we have 2 functions. Every major metropolitan area in the nation has an organization like us. One of our functions is we are the local government membership organization. So our members are all the 7 counties, municipalities, intermediate school districts, and community colleges. So we deal with issues that cross the community borders, like transportation, air quality, water quality. They don't stop at the community boundaries. So our members come to us to discuss collaboration. The other function of SEMCOG is that we are a federally designated regional planning agency. We do regional planning in the areas of transportation, environment, community and economic development, as well as education. So as you can imagine, for all of our work and our members' work, good data is really critical for both community and regional planning. In terms of data, most of our data and maps are on the data map webpage on our semcog.org website. So we deal with demographic data, socioeconomic data, environment, GIS, land use, transportation, and others. So just take transportation, for example. If you go there, there's a submenu that includes bike and pedestrian data, multimodal like transit, freight, safety, traffic volume, and the transportation infrastructure data. And just for example, if you click on the transportation infrastructure, we have bridge conditions data, flood risk tool. As you know, road flooding, freeway flooding has been a huge topic in this region in the last few years. Implemented transportation projects, national function class of roads, pavement conditions. Actually, every year this time when the weather becomes better, we go out to assess the pavement conditions in the region. every year and collect information, data for planning purposes. Road jurisdiction, transportation implementation plan, and regional transportation plan projects. So those are the transportation infrastructure related projects. Community profile is probably our most widely used application. From there, every community, there are 233 of them in the region, can get information for their own community or for their neighbors. And you can combine them to create customized areas. We have a pretty extensive map and application gallery. And then we have an open data portal where users can download data from there. And by the way, all the data we have there is free. So for the next few minutes, I'm going to use our long-term forecast as an example to just show you how we develop and use data for planning purposes. Every 5 years, we do a regional demographic and economic forecast. There are two purposes for doing the forecast. Number one, we want to understand and educate our members about the big trends that are coming. I'm sure you heard about the recent discussions about Michigan population growth or lack of it, and the Governor Whitmer's Grow Michigan Together initiative. So we want to take a closer look at our own region's population trajectory from now to the next 30 years. And another example is we want to understand the impact of the oil industry's transformation from the gas and diesel vehicles to the EVs, and how will that affect our economy and our population. And the other purpose is really to provide base data for both local and regional planning efforts. So the forecast includes population by age, household by type, like household size, age of householder, income, how many children they have, how many workers, how many cars they have. We have also the employment by industry. We model by dozens of industry and publish them at every geography. So in terms of geography, we do the forecast for the entire region. That's where we start by running a computer model. We work with economists in University of Michigan. Model is called REMI, and that's a spatial input-output model, compares how our region is doing economically compared to the rest of the nation, how we compete with other regions in the nation. And there's also a demographic component of it linked to the economic side by labor force participation. We also do the forecast for every county, every community, school district, and traffic analysis zones. Traffic analysis zones, or TAZs, are similar to census tract in size, but they're designed differently, particularly for transportation planning purpose. So it's a process of computer modeling. I talked about REMI model. And when we take the regional forecast down to the local level, we run a different computer model called Urban Sim. And we also get expert input from the region and outside the region, and go through a very intensive local review process, get additional input from the public, from planners, from elected officials, and then we adjust the forecast and make it better. And eventually, this forecast is adopted by SEMCOG policy bodies, the Executive Committee, and General Assembly. So we use that for the forecast, for the planning work for the next 5 years. Just a couple of slides to show our long-term regional forecast. This is population. As you can see, we are growing but very slowly, 6% in 30 years, which is much slower than the US average, which is 15%, 30 years again. And the slow population growth, and particularly the lack of growth in prime working age population set the speed limit for our economic growth or employment growth. The labor shortage issue that has been talked about in the last few years, unfortunately, that's not temporary. That's actually structural. Our economic growth is limited by the availability or lack of the prime working age population. So we also do alternative scenario by changing the assumptions, by changing the input data. This time we look at a couple of EV transformation scenarios. So basically, if the transition to EV is faster, there will be a negative impact on our economy and employment in this region, particularly if the EV vehicle and parts manufacturing and the battery manufacturing disperse outside Michigan. So really our hope is to continue to diversify our economy, particularly in the knowledge-based and export-oriented industries like professional and technical services. So once we finish the regional forecast, the next step is to allocate to smaller geographies. And for that, we use the so-called urban sim model. The urban sim model uses very detailed geography. It's currently operating at the building and parcel level. We have about 1.6 million buildings, this giant database. And then the model itself is mostly based on the discrete choice model by maximizing utilities, trying to simulate consumer behaviors. In this case, it's mostly the location choice behavior. For example, there's a bunch of residential location choice models for different type of households. So it looks like the input data, look like where people live now, and look at the characteristics of their households and the attributes of the location, and trying to understand who are more likely to live where. So basically the households are the choosers, and the entire database of the buildings is the choice set. Thinking about household location choice, the two probably most important independent variables are housing price and income, right? So housing price divided by income is typically in the utility function, and then you add other things about the households and about the site, where the jobs are, how easily you can access to the jobs, where the shopping opportunities are, school quality, crime rate. All those things affect residential location choice, can be considered for modeling the household location decision, so you can predict where people live in the future. We need to know that for planning purposes, like providing services, transit, road, water, sewer. We need to know the future locations of people and jobs and how they commute. Similarly, there are models for business location choice. So you look at retail industry, manufacturing, medical facilities. They all have different preferences for location choice. You build models for them, and you try to predict future location when your region continue to grow. On this chart, so you see the external models, regional control totals are entered here. Travel demand is a big input. So you want to know the impedance or the accessibility to the transportation system. You also have the policy input. So this is a combination of the market force. You're trying to model the market force, but also want to consider the policy decisions like land use regulations, master plans, or zoning in different communities. You can also input special event into the model. No model can model boardroom decisions, right? We just heard GM is moving from Ransom to the new Hudson building next year. We couldn't anticipate that, and no model can do that. But if you know that ahead of time, you can enter that into your modeling system and take that into account in your overall forecast. The blue ones are different sets of input data. I'm going to talk about that a little bit more in the next couple of slides. And the orange squares are the models. So you have a transition model that translate the control totals to the households and population and jobs. You try to model in different types. There's relocation model to deal with people relocate within the region, and the location choice models put them into the right places by calibrating your models. And there's land price model, and based on that, you have a developer model to develop additional buildings, whether it's residential or commercial, industrial, institutional, to accommodate future growth or people moving around. So for input data, and this is closely related to the data I described earlier that we develop all the time. So we have population and household data mostly from census and American Community Survey, and jobs or employment data. We work with Michigan Department of Transportation and work on two employment data sources. The data axle, that's what they're called now, and the Dun and Bradstreet. And those are the establishment level employment data. And we have every parcel, every building in the region, and we collect master plans and sometimes zoning from local communities for policy purposes, transportation, travel time, accessibility, and also special event to feed the model we just saw in the previous slide. Additional information, accessibility, developer model, and job space information, so on and so forth. That's part of our data work, not only for the modeling purpose for this project, and we use that, and we use the data for other planning purposes, and we provide information to local communities and members. And also the private sector can use the data and the forecast as well. For example, like site selection to look at the future locations of customers and things like that. So here's the output. Basically, you get population by age, households by type, housing, employment type. We publish data by 5-year intervals, even though we model at single year. And I know you can't see this very well, but most of the data, including that at multiple geographies from the small TACs to the regional numbers, are on our website in one of the applications Chad and his friends developed. This one is called Forecast Explorer. You're welcome to explore that and see what the forecasts say about the region and the communities. I think that's a good time to transition to Chad, and Chad will tell us some other applications we developed. Chad?
Thanks, Xuan. I'll just hold it. Again, my name is Chad Misiuk. I'm the GIS coordinator at SEMCOG, the Southeast Michigan Council of Governments, and I'm going to be showing an overview of 3 applications that we have at SEMCOG. All of these are available in our map gallery on the website, so if you go to semcog.org, you can get to the map gallery and take a look at these tools for yourself. But I'm going to kind of give a demo of the tool, talk about the development of the particular project, as well as the data that went into that project and how we sort of put it together or processed it, and then talk about some of the coding or the components that are sort of like my favorites, I guess you could say. So first, I'm going to be talking about the Community Explorer. This is a tool that sort of came out of a need to sort of expand upon what we had in our community profiles, which Xuan talked about before. This tool is built using Vue.js, and we're mapping using Mapbox.gl directly from a GeoJSON file. And I'll talk a little bit about that in just a second. And then we also are pulling all of that data into some customized charts that you see on the screen as well. And I'm going to show you a demonstration of that tool right now. So on our website, you can see the Community Explorer tool. So on the left-hand side, you have the map, which lets you hover over communities and see information. There's about 30 different indicators that we've included for the user to choose from. So this really helps our communities when they're like looking to apply for grants, or they want to learn more about their community, or make plans for, about, I guess current sort of demographic information. We try to keep this up to date every year with 5-year ACS data. So you have information like total population, median age, percent people in poverty, and then it breaks it down into different groups. So we have household information like average household size, or you have information on internet like percent households with internet access, and then all the way down to more like economics, like total jobs. And in fact, this information comes directly from our model that Xuan was talking about, the forecast model. This is just showing you the base year data from that model. So in addition to viewing the data by communities, our members can also take a look at it by counties, school districts, as well as census tracts. So if they wanted to, drill in a little bit more, they have that capability. So we wanted to make this application be more dynamic. So we wanted to build in sort of an automated way to classify data. And what we're doing here is every time the map is adjusted or the user is panning around, we're automatically grabbing all of the pieces of data that are on the map, and we're classifying that into natural breaks. So that no matter what level or no matter how many different pieces of data are on the map, we're automatically binning them into categories that give the user the ability to see the patterns more dynamically. So you can see the legend is actually updating as I move around and zoom in, so that you can see a better indication of that particular data set. This is especially helpful if you're going to filter to a particular county. Now you're seeing Oakland County tracks, and they're really kind of dialed into really the data that's in Oakland County. So we feel like this is a really important way for our members to look at information. And so in addition to having the data on the map, we've also built the data into this chart, and you can see that the coloring of the map also ends up sort of reflected into the chart. So it's a way to sort of visualize the classification of the data that's on the map into the data that's on the chart, so you can see what tracks are falling into the different classifications. So a couple of other notes on the Community Explorer. We're using turf.js as well for sort of maintaining the list of features that are on the screen. And we're also using a Python script to sort of grab all of the data that we need. So we have information for counties, communities, school districts, and census tracts. We're bundling that all up using Python and GeoPandas, and we're taking that and combining it into one GeoJSON file. And what we noticed is that over time we were adding more and more to our indicators, because in addition to the actual census data, we're also showing a margin of error. So for every column of data, we also have the margin of error. So we're talking like hundreds and hundreds of columns of data over 1,000 plus pieces of geographies. So we needed a way to try to get that GeoJSON file down in size. And so we came up with a way to use hexadecimals to sort of reduce the size of the data by essentially creating or giving the GeoJSON file a way to sort of shrink itself by not having to name each column in a duplicative way, and that really drastically reduced the size of the file and allowed for it to be consumed in a web-based environment. A couple of the components that I really like are the Mapbox layer, that component that we built. Sorry, I need to use the microphone as my other hand. This particular component is really special because it's allowing us to, we created our own view component so that we could better keep track of the map events that are coming from the user. So when the user clicks on a piece of data or they're hovering over that piece of data, we can keep track of that. But it's also dynamic enough to sort of handle GeoJSON or other forms of sourcing in information. And so I'm not gonna go through this in too much detail, but I just wanted to kind of highlight the fact that we were trying to build a component so that we can add layers to our map and sort of manipulate them and update their colors and their styles really quickly. Because like I was saying before, this is being, whenever the user is changing this or, changing the data shown, this component's being fired constantly. So we needed a way to, make this be very dynamic and very, very quick to be processed. And then we also are generating the raw breakpoints by every time the data is manipulated or changed, or the screen changes view, we're grabbing the geographies and we're calculating the breakpoints using natural breaks, and then using that to drive the map and create the legend and create the classification for the data. I'll show that as well. It's really kind of it's pretty straightforward, like when you just look at it, but you have to keep in mind that this is being calculated, very quickly, and it's happening as the user's interacting with the page. And so what we're able to do is grab the raw values from the information that's in the view, and then we can, break that down into we can grab the max value and the min value, and then we start to build in the classification. And we have different modes that we can use, but for the most part, the data is using the natural breaks functionality. But there were some indicators that we use different types of classification for. So we have the ability to sort of structure that depending on what the data is. Moving along in my development, or my demonstrations, I wanted to switch gears to our crash locations map. So this is a relatively new map that we put out, and I'll show you a quick demonstration of it. It's on our website as well, maps.semcog.org/crash locations. And I wanted to really highlight this and show you how we're able to use really high volumes of data. There's at the user's, fingertips, they have over up to 10 years of crash data, which is over 1 million points of data, and we wanted to give them the ability to visualize this in a more meaningful way. So we're using ArcGIS Online to store this data and kind of take advantage of the caching that ArcGIS Online provides, while also using the ArcGIS API for JavaScript, or the SDK for JavaScript, to do feature binning. So what this does is it takes the point data and it dynamically bins the data into these squares so that you can get sort of a live dynamic binning analysis in the browser. So you can see where these concentrations of injuries are happening in our region, and then you can zoom in and you can see at different levels the bins adjust their size to give you more detail. So you can zoom in and see, oh, like in this, in my community over, on Woodward here, there's, a significant, pocket where there's a lot of crashes happening that are involving injuries. So in addition to visualizing injuries, you can also look at data by total crashes, just the total volume of crashes that are happening, as well as just look at the point data itself, which is what's driving those bins. So the user can filter the data by the counties or communities that they wish to, include in their analysis. They can look at severity, so like crashes that just have a fatal severity level in them, or even just ones that have property damage. And then also you can look at like time of day or the year, as well as like different things like traffic volume. So if you wanted to just look at roads that have a certain traffic volume, you can filter it by that as well. And then you can also look at key factors. So crashes that involved alcohol or that did not involve alcohol. There's different ways to I guess, slice up the data depending on what you need. And then once you've sort of like found that, you found this data set and you've filtered it down, in addition to the URL sort of capturing what your choices are, you also are able to generate a download of like a file geodatabase or an Excel file so that you can download the crashes individually and take them on and further analyze them. So yeah, I already mentioned the data stack, the data stored in ArcGIS Online, and we're using View 3 with Vite as the development stack, and we're using the ArcGIS SDK for JavaScript, and for the filters that let you have multiple selections, we're using the View Multi-Select tool or library. And then I'm just for the sake of time, I want to make sure there's time for questions. I'm not going to go through every single one of my favorites, but I wanted to just mention that for the data download, that piece, that was really interesting because I was able to use the ArcGIS Online infrastructure so that we can generate the download for the user and have it be dynamically based on the filter. I found that to be really interesting, and also just the fact that we're able to sort of like capture what the filters are and apply that to the layers. I found that the being able to use View's ability to watch for changes in different pieces of data that are on the site allow us to make sure that the map is feeling very dynamic and very customizable for the end user. And so there's a particular watch that's on the filter piece of data, and whenever that filter changes, so whenever the user is modifying what community they want to see or what severity they want to see, we're keeping track of that, and then we're setting the definition expression on the layer so that we can update the map and then also take advantage of the caching. So that's one big thing that we noticed, is that once we started using the definition expression to set the filtering, we noticed a big improvement in performance because there's two different ways to filter the data. You can do it client side or server side, and we found that by adding indexes on the fields that we're filtering and using the definition expression, we get much better performance. And then the last tool that I wanted to show is our labor shed tool. So this is also built using Vue and Mapbox, but it's a little bit different from the first tool because we're also using data coming from Carto. So we're sort of tapping into essentially what is a Postgres database in the cloud, and we're dynamically generating Mapbox vector tiles from Carto and then pushing them into the map. So just a quick demonstration of that. The labor shed map is a tool for looking at where Michigan workers live, work, and then sort of like the connections in between. And so this tool, I encourage you to go and check it out and play with it because I don't have a lot of time to give a full demonstration of it. But really, what I think is the coolest piece is the commuter flow. So you can basically see wherever, for tracks that people live in, so for people that live in this track, the blue circles are showing where they commute to go to work. And so you can kind of get a sense for like, you can look at outflow or inflow, so you can see, okay, well, people that work in this tract, and the red circles are where they live, so like where they're coming from to work in this particular tract. And so again, we're using that dynamic sort of classification in this as well, so that you can really hone in on workers by residence, or you can choose to look at it by workplace, so you can see, okay, where are there a lot of density of workers by census tracts, and you can drag this around and see like, okay, where is the concentration of people, where do they live in the region. So I think this is an extremely powerful planning tool for our members, and I really encourage you to check it out for yourself because it's really fascinating. This is using data from the census. It's using CTPP travel information, and there's a lot of capability here for looking at this commuter flow as well as just looking at the different categories. So in addition to looking at the commuter flow, you can also look at specific occupations and then specific industries as well. So if you wanted to look at the construction industry or the manufacturing industry, we have the ability for you to filter that data on the map and look at it sort of depending on what your needs are. So the one component that I wanted to show on this map was the Carto layer. So this is sort of a wrapper around what we built as the Mapbox layer, and it lets you sorry. There we go. So it wraps around the Mapbox layer that I talked about before, but it's letting you pipe in a query, a SQL query, that essentially is going to act as your filter for the data. So it's going to take the SQL query, it's going to go to Carto, build your Mapbox vector tiles, and then bring them back to the client and push them into Mapbox GL as a vector tile. So to Mapbox, these are just vector tiles, but they're coming from Carto, who's delivering them to us in a cached way that lets the map stay relatively performant. And so we build this URL, and we do a quick check to see if it's less than 2048, we do it as a get. Otherwise, we do a post, and we bring in the SQL as a essentially a parameter that lets you add that as an option to Carto's API, and lets you essentially let the user do some filtering. That gets sent to Carto, and then you get to view the results on the page. And so all that's happening because we've created the Carto layer. And so this is flexible enough for us to add several different Carto layers, all with their own sort of SQL statement that's defining what is being shown on the map. And so yes, I encourage you to check out all 3 of these maps in addition to the Forecast Explorer that Xuan was talking about on our website. So you can just go to semcog.org and go to our menu and go to the Data and Maps section and the Maps and Apps gallery, and you can look at all of these maps that we have available online. So I do want to thank you, and also I just wanted to see if there's any questions around the room about any of the stuff that we talked about today. Yeah.
So I had a question earlier, and then when we got to labor shed, it started to answer the question. You're taking like the ACS data and the geo mapping, and you're starting to add another dimension or another layer on it, like proximity. We're doing similar things at Forgotten Harvest, where we're dealing with poverty index. We're doing ACS data. We're doing geo mapping, agencies, supply, demand. My question to you is, are you starting to look into the future at even more complex, multi-dimensional models where you're bringing these multiple things into multiple layers that can come and go? Anything like that? Because it looks like you're starting to do that in this labor shed model, like I'm saying.
That's a really good question. I would say that my answer is probably no, not right now. But I feel like we have the ability to look into doing something like that, especially with some of the forecasting work that we're doing. And I think that that's kind of tricky. I don't know, Xuan, do you have any?
It seems like you've got the tools in place. You've built so much equity in your tools, and maybe starting to have some fun playing with bringing them together in multiple layered technique.
Yeah, I think that's a really great idea. I think it's just figuring out how to do that in an effective way in a browser, I think is tricky, because we've looked at, how do we capitalize on some of these things and make sure that the user is still able to do that on their browser without it, becoming too much of a sort of a hit to their computer and that sort of thing. So I think that we're trying to give people as much information as possible, without without trying to. We want them to be able to make the decisions that they need to make. Yeah. So great question though. Thanks. Any other questions? Yeah.
I guess I just sort of echo that. I'm actually, this is very exciting to me because I'm also a planning commissioner in Muskegon. And basically there's, I think, a lot of new intersections that you could identify between data points that, if we can merge some of these seemingly unrelated maps, we'd find a lot of new conversations and ways to engage. So you've done a lot of that work, but I think that if we can make some more of those connections, we can apply a lot of those things in policy.
Yeah, for sure. I think that's kind of the tricky part, right? Like figuring out what could be connected to each other. I think that's what I struggle with the most, is like, I'm not really a planner by trade. I, went to school for GIS, so I think about the map and I think about the capabilities, but, making the connections is kind of a whole nother ballgame. Thank you. Any other questions? I think we're just about out of time. Awesome. Well, thanks again. Thank you for coming. Appreciate it. Feel free to ask any other questions of me or Xuan if you see us around. And yeah, have a good day.
Thank you.